Alright, the heat evolution talk. Sun, G2 star, orange dwarf. Yeah, it's not really all that hot in the center. Just the yellow right there is the outside of it. It radiates most of its heat away. But as it starts contracting, the interior will begin heating up. Eventually, when the core starts forming, then the interior heats up even more and it starts becoming fully convective in the interior and it starts to get really, really hot. And this is when the global field takes over right here because the core is starting to form. And the basic note is as it contracts, the interior heats up and the exterior cools down. So a lot of the heat that isn't radiated away is saved for the interior as the material becomes more gaseous from its plasmatic state. Eventually you have, a brown dwarf where just infrared heat is trying to escape. And you get a later stage brown dwarf. And then I drew a box here to show that there's a very thick atmosphere and the interior keeps all the heat and is in the layers. Eventually, from that stage, it goes to here, and the heat is still in the center as, it's becoming liquid and solid material. And the heat is, trapped because the atmosphere won't let it go. There's a high thermal resist. No, there's a R. I want to say R value, but it's a very high R value of a thick atmosphere like that. So it traps the heat for very long periods of time. When you don't have the star radiating the heat outwards, it can trap it when there's gas completely covering it. And then you have much older stars. Keeps the heat, just stays put, and it cools down, escapes from the surface, cools down, cools down, cools down. Eventually, you just have a little rocky ball of completely solidified matter because all the heat has been dissipated through volcanoes and geothermal vents and that kind of activity. But basically, that's the heat evolution. I know it's kind of crude drawings here, but you have the star containing the heat and not shining from its own light. That's what I want people to know. That's the number one thing, is that the star internalizes the heat and it keeps the star very hot for very long periods of time. And as the atmosphere is ripped away, then its protective layers are ripped away, and then it loses heat in other ways. Another way of looking at this is very hot plasmatic and gaseous, and begin like having more liquid material, and that liquid material will begin solidifying in the interior and cooling down, cooling down, cooling down. Eventually leaving just a little ball at the end of it. Yeah, that's basically it. Hopefully that makes a little more sense. This is still really new to me, to be honest with you. All right, today is March 6, 2016.